this video, we will be discussing about bitwise XOR of all pairings. You are given two zero-indexed arrays nums1 and nums2 consisting of non-negative integers. There exists another array nums3 which contains the bitwise XOR of all pairings of integers between nums1 and nums2. Every integer in nums1 is paired with every integer in nums2 exactly once. Return the bitwise XOR of all integers in nums3. So what they are saying is that in the input, we are given two integer arrays, nums1 and nums2. Now, there is a third array, nums3. In this array, what do is that we do the XOR of each element of nums1 with each element of nums2 exactly once. So basically this 2 is XORed with 10, 2, 5, 0. Then this one is XORed with again all of these elements and then 3 also, right? So basically here we have 2 XOR 10, 2 XOR 2, 2 XOR 5, 2 XOR 0, 1 XOR 10, 1 XOR 2, 1 XOR 5, 1 XOR 0, and then for 3, 3 XOR 10, 3 XOR 2, 3 XOR 5, and 3 XOR 0. So this is the third array nums3. Now what we need to do is that we need to find out the XOR of all these elements, and that is going to be our answer, right? So basically we need to do XOR here also, right? And then whatever is the value that we are getting, that is our answer, right? So see, how can we solve this? So the brute force approach would be that run a for loop equal to the length of nums1. Inside that run a loop for nums2, right? So basically if the length of nums1 is n and that of nums2 is m. So first you will run a for loop of I starting from 0 to n. Inside that you will run a for loop of j starting from 0 to m. And then you can find out the XOR of nums1 of I and nums2 of j, right? And you can keep on finding it and doing the XOR in some variable, and at the end you can return that XOR as your answer, right? But here the maximum size of nums1 and nums2 can be 10 to the power 5, right? And since you are running a for loop n times, inside that n times, so it will be n cross m times, right? So 10 to the power 5 n cross m will not work. So we will have to think of some optimized approach, right? So we will apply some of our bitwise XOR properties over here to optimize our solution, and also we will try to find out some key observations from this array. So if you closely look, each and every element of nums1 is being XORed with each and every element of nums2. So if you see that how many times is this 2 being XORed over here? So it is 1, 2, 3 and 4 times, right? And this 4 is nothing but the length of nums2, right? Then again if we see for 1, so this is also being XORed 4 times, which is nothing but the length of nums2. Similarly for 3 also, right? So basically all the elements in nums1 are being XORed equal to the length of nums2 times, right? And if we see for the elements in nums2, so 10. So 10 here is being XORed 3 times, which is nothing but the length of nums1. Similarly for 2, 5, and 0, right? So basically all the elements in nums2 are being XORed equal to the length of nums1 times, right? So what can I say is that 2 XOR 1 XOR 3 is being XORed equal to the length of nums2 times, and 10 XOR 2 XOR 5 XOR 0 is being XORed equal to the length of nums1 times, right? So why I have done an XOR over here? Because ultimately also we are doing the XOR of all these elements. So basically here, instead of considering this as a single element, we can consider these elements as individual elements, right? Because all of them are being XORed at the end, right? So that is why I am saying that 2 XOR 1 XOR 3. This is happening how many times? Equal to the length of nums2, right? 1, 2, 3 and 4, right? So now there are few properties of XOR that when we do the XOR of a number with itself, we get a 0. And when we do the XOR of a number with 0, we get the number itself, right? So if we consider that the number is 1, 0, 0, right? So in an XOR, 0 XOR 0 gives 0, 1 XOR 1 gives 0, 1 XOR 0 or 0 XOR 1 gives a 1, right? So if I do the XOR of a number with itself, 0 XOR 0 will be 0. This will also be 0. 1 XOR 1 will also be 0. So when I do the XOR of a number with itself, I get a 0, which is this particular property, right? And when I do the XOR of a number with 0, then 0 XOR 0, 0, 0 XOR 0, 0, and 1 XOR 0 will be 1. So when I do the XOR of a number with 0, then I get the number itself, which is this property, right? So these two properties we understood. Now, if you closely look, this particular thing, if I consider it as x, so x is being XORed equal to the length of nums2 times, which is 4, right? Basically, we are doing the XOR of x 4 times. So it will be x XOR x XOR x XOR x, right? Now, what is going to be the result of this? So when a number is being XORed with itself, we get a 0, right? So this will give you a 0, this will also give you a 0, and then 0 XOR 0 will also give a 0, right? So there is one conclusion that you can make over here, that when particular number is being XORed even a number of times, then the answer is 0, right? Whenever a number is being XORed even number of times, the answer is 0. Then if you see over here, this particular thing if we consider as y, so this is being XORed equal to the length of nums1, which is 1, 2, 3, right? So y is being XORed 3 times, right? So it will be y XOR y XOR y. So y XOR y will give you a 0, 0 XOR y will give you the number itself, which is y. So then that means when a particular element is being XORed odd number of times, then we are getting the element itself. So these are the two observations that we have made. Now we will apply these two observations over our answer, right, for finding out our answer. So see, this is being XORed equal to the length of nums2, and nums2 length is 4, which is even. So then that means the answer of this will be 0. So we can say that the answer of this entire thing will be 0. Then if we consider this one, so this is 3. The XOR of this is happening 3 times, which is odd. So the answer of this is y. What is y? This particular thing, right? 10 XOR 2 XOR 5 XOR 0, right? What will be its answer? I think it will be 13, right? So the answer of this entire thing will be 13. So then what we can simply do is that we will do 0 XOR 13. So it will give us the number itself, which is 13. So for this particular case, 13 is going to be our answer. So this is what we need to do, right? So simply what you can do is that first of all, for this, you can check that is the length of nums2 even or odd. If it is even, then for this, the answer will be straight away 0. And if it is odd, then you can just find out the XOR of all the elements in nums1, right? So that will be your XOR 1, you can say, right? Initially, you can keep it as 0, right? So if the length of nums2 is odd, only then you can find out the XOR of all these elements and keep in XOR 1. Then you can take another variable XOR 2 equals to 0, right? And then you can check that what is the length of nums1. If it is even, then we will keep it as 0 only. But if it is odd, then we will find out the XOR of all the elements in nums2 and we will update in XOR 2, right? And at the end, we can simply return XOR 1, XOR, XOR 2. This is our answer. So this is what we need to do. So here we will be running only one loop inside nums1 and only one loop inside nums2. So if let us suppose that the length of nums1 is n and that of nums2 is m, so the time complexity will be order of n plus m. And we will not be taking any extra space, so the space complexity will be constant, right? So let's quickly look at the code. So first of all, let's create our two variables, XOR 1 equals to 0, XOR 2 equals to 0, right? Then we will check that if nums2 dot size modulo 2 is not equals to 0, meaning it is odd. So we will identify the XOR of all elements in nums1. So for int num in nums1, what we will do in XOR 1, we will do the XOR of num, right? Same thing we will do that if nums1 dot size modulo 2 is not equals to 0, then for int num in nums2, we will update XOR 2 to the XOR of num, right? And then at the end, we will simply return XOR 1, XOR, XOR 2, right? Let's run this. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.